You need the podium. Do I unplug or do you?
What? Whenever you're ready, I'll start the intros and we'll just get going. And then you'll be the first speaker. Does that sound okay? I don't need your computer.
Cool. Sounds good.
All right. All right. So, okay. Hello, everybody. You're in the right place for San Diego Python. And if you're on the live stream, I'm terribly sorry. Our AV is not working today. I'm not sure what has changed exactly. It's possible the adapter that I have is dead. Anyway, I'm David. You're in the right place for San Diego Python. I do want to thank Qualcomm for having us, and specifically Uriban for managing the door and helping people in and everything. And I know probably not too many people are here because we're going up against the US game, but so it goes. The pizza is thanks to Cloudflare. I'm going to do a Cloudflare slide maybe after Hobson's presentation, so we'll do that. Really, again, sorry about the live stream. I did want to talk about, there's a Saturday meetup. It's Saturday, it's 10 a.m. All the info's on the meetup page. That one is virtual, it meets on Discord, and it's a little bit different. It's more of like an open discussion roundtable kind of a meetup rather than this one, which is like talks and presentations. There's a website for San Diego Python, it's sandiegopython.org. There's a YouTube channel, which normally this is live streamed with like capturing the slides and everything, and that's not happening today. That's linked from the webpage, or it's youtube.com/@SanDiegoPython. And the link to Discord is also on the website, so all the things are from there. I do want to talk about a couple upcoming conferences that are coming up. Pi Ohio is in Cleveland, July 25th to 26th. So if you're in the Cleveland area, I know that's far, but so it goes. DjangoCon US is in Chicago this year. It's going to be August 24th to 28th, so that's really cool. And if you have not gotten your Pi Beach tickets already, they are on sale. Pi Beach will be in Santa Monica this year. It's Saturday, October 24th. The CFP is now closed, but I think the early bird tickets, I think there's still a couple available. But yeah, it's a one-day, one-track, cool conference downtown Santa Monica. So yeah, and then from a speaker perspective, the most important link on the website is the San Diego Python, on the San Diego Python website is to become a speaker. So you can present at a meetup, and hopefully we're not having AV issues when that happens. Awesome. I think that's pretty much all my intros. Hobson, I'm going to let you take it away. You're our first speaker. Hobson Lane is going to talk to us about Bayes rule and optuna Python packaging for optimizing anything, which sounds ambitious. And I'm going to give you this somewhere. Yeah, so you can pin it to yourself. I'll let you take it away.
Optuna and the Bayes rule. Sounds a bit like a band name when I title heard David say. So optuna is a Python package. The Bayes rule is a thinking tool for you in your life, and it turns out it's probably how your brain works. I've been going to a lot of cafes, doing a lot of coding. For the past 3 weeks, I've been training a model that's really urgent, so I've been having to go back and forth from my fast local connection to my GPU to the cafe for fast upload to the place where it needs to be. Anyway, I've noticed a lot of people coughing around me. This is the flu proportion of people who have flu and the proportion of those who have COVID and don't know it. Anyway, these are people that sent in their saliva to get tested, and either they had influenza or they had, and we're right here at the end where we're getting an uptick. San Diego seems to be a lot worse than these global statistics, at least in my personal experience. About every third or fourth person is coughing right near me. What is Bayes' rule? Sorry, it's a little bit small, but the way I remember it is this first equation, this first line of equations. The probability of one event given another event times the probability of that event equals the probability of You notice how it looks a little bit like a fraction, and you're taking the denominator and putting it up in the numerator, that probability of B. You can think of that vertical bar that given that this B event has happened. Anyway, this represents things like symptoms in disease, or a test result in a disease, or a hypothesis and an actual fact. So for instance, if A is the probability that you have COVID, given, and the B is given that you've had a positive test result for COVID. So you need to multiply that by the probability of that COVID test result happening to anyone, and then you have to, and that equals to the probability of that test result given that you have COVID, and multiplied by the probability of people that have COVID. So if you this is the easiest way for me to remember it, or the second line, where you just take that probability that somebody gets a positive test result and put that in the denominator. And that's the hard one to calculate, so you have to break it apart into the probability that you get a positive test result when you do have COVID, and the probability that you get a positive test result when you don't have COVID. And you need to multiply both of those by their probability, their respective probabilities, the probability of people that have COVID and the probability of people that do not have COVID. And so this is how our brain works. We're doing, all of our neurons are voting on things, trying to predict the future. And they're getting statistics. Each of the symptoms of COVID, or the tests of COVID, or the tests of, is this person happy or sad with me right now? Our empathetic neurons, they're all firing, voting, and creating these statistics in our head. And we have a memory so that we carry them over from one experiment to the next, so that those neurons fire more often if they get it right. And so they're computing, many neuroscientists think that for most predictive tasks, we're trying to optimize Bayes' rule. Well, screening example, if you run these numbers on these statistics for like pancreatic cancer, these numbers are a little low. So this is saying that 1 in 100,000 people have pancreatic cancer. It's more like 30. But if you run these numbers through and of course, and there's the 10 number is the, shoot, I've forgotten what all these numbers represent, but there's a number for the number of people there's the accuracy rate for the test itself for pancreatic cancer, and it all comes out to, if you run these numbers for these low probabilities, even if you get a positive test result on pancreatic cancer, that one data point is going to only give you a 9% chance of actually having pancreatic cancer. And so you need a corroborating test, a biopsy or something else, before the doctor's going to do anything extreme. And that's why there's another insight or thinking tool to remember, is that for things like breast cancer and more common cancers than pancreatic cancer, be really careful about applying Bayes' rule. And if your doctor doesn't know it, ask him about the numbers you need to calculate it yourself. Because a lot of the interventions and the additional tests you might do for a particular disease can be harmful to your health. And they can actually increase the likelihood of you getting a disease. And so, especially things like mastectomy, which can have a severe impact on a lot of things in your life. So I've trained a model, like I talked about it for the past 3 weeks. I've been using this thing called optuna to train a model. What it does is it optimizes that model. It makes it more accurate. It tries to figure out, what did you do wrong? And those initial guesses on how you put together that model. Maybe you use a linear regression, maybe you use a logistic regression, maybe you used the wrong features or whatever. You can use what's called hyperparameter optimization to optimize for those things. So those things, so this is, I like the name, I've never liked the name hyperparameters or hyperparameter tuning. I prefer, it's kind of like meta learning. It's learning at a level above the machine learning model itself. In reality, it's because the scientist is applying, the data scientist is applying their learning of their intuitions across all the experiments they've ever done to choose things like learning rate, or the number of layers or neurons in a particular neural net, or they're architecting a system based on their own intuition, their own hypotheses. And so that's a predictive model, and you can do machine learning on it. And this Bayes rule is the most powerful, most accurate, most explainable way to do reasoning about those sorts of things. And you can learn a lot when you're using it. This is a small portion of all the models I trained. And I'll show you a learning curve in just a second so you can see how long these take. But each epoch is typically around 10 minutes to an hour. Just for reference, for a large language model, an epoch is in the order of days. Even if you're trying to train a language model yourself on a large GPU, it would, on say the corpus of Gutenberg books, some subset of all the high literature in Gutenberg, that would take you at least a day for a model that's probably 20th the size of your typical like Llama 2B. And so each one of these experiments, each one of these training runs is extremely expensive. And that's why you use something a little bit better than a linear regression. You could do a linear regression to this table. So you have a table, I call this the hyperparameter table or the meta table, the meta parameter table. And this tells you, you need to, like a scientist always does, you record your experiments in a logbook. It was really expensive to go into that lab and do a bioassay or to train a model for a night while you're sleeping. And so you don't want to have to do that again, so you write down the results of that test. And you try to remember everything you did in that test. So the hyperparameters are everything, literally everything, including the version of code you use. Because you never know when you're going to put some little extra number in somewhere in your code, or you're going to run something a little bit out of order. Even the random seed is important and should be recorded in your hyperparameter table. This is a subset of the things that I record automatically, of course, for every trial run that I do. These are typically called studies when you do multiple training runs or trials. Optuna calls them studies, and they call each training run a trial. In case you ever want to use this yourself. And you don't have to just do it on machine learning. You can do it, it's designed to optimize the output of a function. So either minimize or maximize some variable. Like in this case, the output is the test results at the end of training a model, or what's called the validation accuracy. You have the training set that it gets to see. You have the validation set that it only gets to see at the end of an epoch, where you ask it to answer those questions in the validation set. And if it gets them right, it gets a point. And if it gets them wrong, it gets a negative point. And the percent right is the accuracy. And that's the number you're trying to maximize. Optuna, just so you know, just for your reference, if you use it, it minimizes everything. So if you give it a number that you want to maximize, it just computes the negative of that number before it runs its magic. So here's those learning curves. Who knows what a learning curve is? It's kind of like a learning curve for a human. Anyone want to make a guess? What's a learning curve for a human? Somebody. Surely you've heard that term before by your teacher or your boss who's saying, that's a steep learning curve for. Yeah. Sorry? Yeah, so I guess there's a lot of different people's impressions of what it means, and my personal impression of it is how hard it is, how steep it is to climb up the learning curve. So I think of it as the opposite of this, where. But anyway, the learning curves from machine learning are they're showing you the increase in accuracy over time. And time is measured in epochs. An epoch is one run through, one reading of your data. So if you're training a large language model on all of Wikipedia, then it would be one read of every article in Wikipedia. All the tokens being tokenized, all funneled through your language model to predict the next token. Each time it's, and recursively doing that for passages of text that are the chunks of size that you want over the window of what's called the context window in a large language model. So if you're training a really big one, like ChatGPT or Claude, you're talking 1 million tokens. So it's not reading one article, it's reading a whole chapter of a book. And the tokens are smaller than words, but typically, but nonetheless, it's a lot of words. But for, if you're doing this on your laptop, like that 1 day epoch that I was mentioning that you can do yourself, that you're talking about only a context window of maybe 512 or 256 in your total context window that you're the number of words that you're going to try to remember and make sense of to generate the very next token. So these take a long time. You can see that I cut some of them off early, even the ones that are winning. That green one, because you can see one you can see a nice, oh, you can't see my mouse. Here we go. So this blue one at the top, that is it starts out really jagged. That's the learning rate effect. So the learning rate is how much of the slope, you can see the slope. So it goes through a batch, it goes through, say, 100 samples of your data. Maybe you've got 1 million samples and it goes through 100 of them, and it measures the slope on those examples for each of the neurons at the output layer. And that slope tells it, okay, I need to move, and it splits it up evenly across all of them, and then propagates that back through based on the weights that are already there. So if one of them was really responsible for that prediction it just made, and it got it wrong, that's a negative slope on that one, and positive slope on all the others, but you're gonna, that they got right, and you're gonna calculate the amount that you wanna change it. And if that was an actual accurate prediction of exactly what's happening, then you would be able to know exactly what the weights need to change to. But it's always an approximation. This is just a small sample of them. If you change the neurons for the word the, and you don't change it for the word a or whatever, then you're gonna have a problem on the next batch that uses a lot of a's instead of these. And so to mean the same thing. And so you don't want to use all of the information you have about the ones you got right and try to force it to get that exact answer right for that batch. You get a part of it, and that's what the learning rate is. It's how much, it's the proportion of the right answers that you actually want to achieve on that epoch. And of course, and it bounces around because it gets it wrong. Within an epoch, or within the whole epoch, it's gonna be calculating those slopes, doing that back propagation in a different order. It shuffles them each time. And so each time it's gonna get a different slope, and the weights are gonna be different each time. So it's gonna tend to be jagged. If you have, this is one of those intuitions about hyperparameter tuning that a data scientist knows. If you start to see that, if it's too jagged, if you're learning too fast, then you probably need to crank down your learning rate. So my learning rate is typically 0.1% on this particular application. This application is trying to predict molecules, trying to predict molecular reactions that can be used to create a molecule. This is used in drug discovery. You need to know how to synthesize a molecule. Once you learn what you think are going to be the molecular properties of this molecule in your body, then you need to figure out a way to make it. And this gives you the set of reactions you can use with things you can buy off the shelf that you can use to make it. But I was talking about learning rate, and it automatically scales back on its learning rate as it gets smarter and smarter, because it's not, when it sees it's not making much progress or it's making negative progress, it tries to reduce the jaggedness. And so that's why I cut it off at the end, because the learning rate was so small, it's not going to go anywhere fast. So I'd be much better off training on something else. That was probably the most recent one anyway. Data science, nerding out. So what's a good way to choose your next hyperparameters? Well, you could try all the different numbers of layers. That model you just saw there had 24 layers, that one that did really well. I tried another one at 27 layers. I tried a lot at 12 layers. Of course, I start with the small ones because they train faster, and I can learn what all the other parameters could be. So I could have put in 12, 13, 14, 15, 16, and I could train all of those layers. Say that added up to 15 different models. Okay, great, no problem. I can do that. If each one of these takes 8 hours or 12 hours, we're talking a reasonable number of days. Oh, but I forgot. I need to also think about the initial learning rate. I have a guess that 0.1% is the right number, but maybe 1% is the right number, or maybe even 10%. So we can try those, or maybe the number of estimators, or the number of neurons on a particular layer, or the hidden layer depth, or in a transformer like this is the number of heads, the number of attention heads that you've got in it. This particular model that's called a decision transformer has only 3 heads. So I could use 3, 5, or 3 or 4 or 5 heads. And this is doing a tree search, so you can also explore that tree deeper. So a max depth of 3, 5, or 10. Now, how many, if I've got 15 learning rates, if I got 15 layer numbers, I've got, let's say, 3 learning rates, I've got 3 hidden layer sizes, and I've got 3 max depths. So those 3 times 3s, those are 9s, or close to 10s. And then you get another, so you're talking plus the 15, so you're talking about 3 or 4 10s multiplied by each other. And that gets to be too many experiments for me to conclude in my lifetime. So you got to do something better. That would be called grid search. If you're trying to search exhaustively everything, just incrementally going through each one of them. Once you get done with all the layers, now I can work on each one of the layers. It's a nested for loop throughout a linear list of all of the parameters. Optuna does it better. Turns out you'd be much better off just randomly guessing. And of course, the random guess that a data scientist makes will be even better than the random guess of a roll of the dice. It turns out that it will test many more combinations faster, because often it's a combination of things. Like when you increase the number of heads, you probably want to reduce the number of layers. There's a lot of relationships between all these variables and how they interact with your final answer. So you really want to vary them all simultaneously. There's a lots of optimization research in all the different ways you can do it. The good old Bayes rule turns out to be the best for most people. So it's typically used within optuna. All I've done is change the letters A and B to H and E. And where H is a hypothesis and an E is the evidence. So it's what you get out from a particular experiment or an experiment. So you just apply this same equation, and it will give you a new best estimate of your hypothesis for that variable. So if your hypothesis is that you need 24 layers, then this equation, based on the evidence of your last trial and how much accuracy you got out of it, the probability, those are all probabilities. They're the number that you got correct. So this will tell you what you need to do, what your next hypothesis should be, that you should test with an experiment in your hyperparameter tuning. I didn't write this, so I'm not going to discuss it. TPE, that is something that Optuna, this is the default algorithm for that Optuna uses. Tree structured partisan estimator. So like I was mentioning, these variables often depend on each other. And so it's creating a tree, sort of like a random forest learning, using the Bayes rule to optimize that next best estimate. It's basically just a tweaking of Bayes rule to work in pairs and to not model all of your parameters independently, but to model them within a hierarchy that it learns from your data, from your experiments. All of this is done automatically in Optuna, and so that's it for my talk. Here's a quick, you can see how little you need to do to run an Optuna study. You just give it a list of options for each of your parameters, give it your function that you want it to optimize for, and it will go and do it. And you can do things like, okay, the learning rate is scaled logarithmically, so I want it to be a low number of 0.01% like I described and 10% on the high side, and I want you to try on a logarithmic scale between them. So I want you to try 0.01, 0.001, and 0.1. I don't want you to try 0.1 and 0.9, 0.09 and 0.08 and so on. So it does a really good, and it's creating probability distributions because that's what Bayes' rule does. If you assume everything is Gaussian once you combine enough things together, and so if you just assume that all these parameters are distributed either Gaussian or log Gaussian, then then you'll never go wrong. And Optuna does all that math behind the scenes for you. That's it. Can anybody guess who I had write those slides that I didn't write? Yes. Yes. Oh yeah. I never talk about anything that's not open source, free open source, FOSS. Oh no. This is a package that's by Bergstrom, I think it was. I forget where I've heard that name before, but he's famous for a lot of things. Maybe Keras. He was involved in Keras, I think. PyTorch is a completely different animal. So PyTorch is doing gradient descent. It's keeping track of all those slopes I was talking about. Optuna is just computing the Bayes rule on the output of something like a PyTorch model that's doing the learning in a tight loop that happens very fast. So you can calculate slopes really fast and you can apply them to millions of neurons very fast. It's all done on a GPU where you can do these matrix multiplications very, very fast because it's just, that's all a slope, a linear regression is a matrix multiplication, and that's all it's doing. It's a numerical gradient descent algorithm that accomplishes the same thing numerically as logistic regression, which is just linear regression on an exponential function. That's it. So it's equivalent to a linear regression if you squint your eyes a little bit. Go for it. Well, that particular model, it depends on the model, it depends on the problem, depends on how hard it is. So you can use the model right at the very beginning, it just won't be as good. So you just typically keep going until you see that plateau and it's not getting any better. And for me, on this particular problem of modeling molecules with a 24-layer neuron and about 50,000 examples of those reaction pathways, they're called, it took up to 150. The paper that I was getting this model from, they used 300 epochs, but with optuna, I was able to get it done a lot faster. All this on an AMD GPU that's cheap.
Hopefully this works. All right. Oh, and Hobson, can I get you to just take a photo on a phone of when I get the slide up?
Sure.
Thank you. And try to get some of the audience. This is for the sponsor so that I can get reimbursed on the pizza. No, I don't need a video, just a picture. Okay. Hey, the slide came right up. That's pretty good. Let me mirror these displays, and then hopefully things are good. Okay. Yay. Okay. Oh, I have my notes on this thing. Sorry about that. Okay. Thanks again. So the pizza for this meetup is brought to you by Cloudflare, and my presentation is going to talk a little bit about them just because this was very timely for my work. But Cloudflare makes networks and websites faster and more secure. They provide awesome tools like web app firewalls, DDoS protection, R2, which is an S3 compatible storage engine, and much, much more. The Cloudflare network is absolutely massive, and 95% of internet connected people are within 50 milliseconds of a Cloudflare node. And this makes your site or network fast for people all over the world. Check it out, and the free plan is really generous, and the SDPython website uses it. So thanks, Cloudflare. All right, cool. And my presentation, like somewhat, I guess somewhat coincidentally, is also going to talk a little bit. Oops, that was not what I wanted. Somewhere I have this file that has the presentation on it. There it is. All right, and then we'll present this thing. Okay, awesome. So my talk is also going to talk a little bit about DDoS attacks. So first of all, I'll say I'm the speaker of last resort at the meetup when nobody else is here to give a talk, and I acknowledge the US game is on right now, so you know, I get it. But when nobody else is giving a talk, I'm the speaker of last resort. And I let people vote in Discord, and this is what they wanted to hear. They wanted to hear a talk about DDoS attacks. So because my company has been under a DDoS attack this month, I figured this would be particularly timely. So I'm going to talk about the anatomy and mitigations of a DDoS attack. So I guess the first thing is let's define the terms. What is a DDoS attack? Cloudflare defines it as a distributed denial of service attack. It's a malicious attack to disrupt the normal traffic of a targeted server, service, or network. And you know, there are a couple different ways that those are accomplished. And this is the one that I'm going to be mostly talking about today, which is called a volumetric DDoS attack. There's other kinds. But this is basically overloading a service with too many requests, too much volume, And the goal is to interrupt real users from using the service. I also should mention that this can attack at various layers. You can attack at the IP layer, you can attack at the TLS layer. But for this talk, I'm going to be talking about what's called layer 7 attacks. And this is basically the HTTP layer. So above all those other layers, it's possible to attack at those other layers, but that's what I'm going to be talking about today is the layer 7 attack. And Cloudflare does sponsor the San Diego Python Meetup. I'm going to be honest about it. And my company is a paid Cloudflare customer. So a lot of what I'm going to talk about is going to talk about Cloudflare, although I'm going to try to give examples and some of the mitigations more generally and talk about some of the alternatives. But a lot of my experience is with Cloudflare just because that's what we use at work and that's what I know. So I'll do my best, but I'll try to be generic about it. But this is, we were generally happy with Cloudflare, so that's going to come through in this talk. So this is kind of the what does it look like in practice, and hopefully you can kind of see this. And this is what it looked like for my company. We saw basically all of a sudden huge surges of traffic to 100x normal levels. We served about 20 billion requests in a week. This would be like suddenly like a medium traffic web blog becoming the #1 website in North America or something like just crazy numbers. No aspect of this made sense. Yeah, and I don't really, it's very unclear to me what these people were trying to accomplish, but I guess I'll talk about the next part, but this was clearly a targeted attack targeted at us. So at the peak, we were receiving 5.5 million requests a minute. Just to give you like our normal baseline of even like peak traffic, our traffic is highly variable over the course of the day. Normal work times are peak traffic. Nighttime US is like the lull in the traffic. But even like peak normal daytime traffic is less than 100,000 requests a minute. So this was 100x normal peak immediately. The attack was coming from millions of IPs, all spread out all over the globe, hundreds of unique networks. So there wasn't really anything there that was super obvious, like what do you block? Residential IPs were part of the attack. In fact, my own, I'm a Cox customer, but I saw that there were attacking IPs coming from Cox San Diego. So, yeah, we'll get to that. Attackers were randomizing TLS headers to avoid any sort of fingerprinting. They were specifically targeting URLs designed to avoid cache hits. So temporary redirects, 404s, unique paths, multiple hosts that all resolved to us, lots of stuff like that. And Cloudflare, our CDN, did not stop this attack entirely out of the box or something like that. It wasn't just like click the DDOS button, problem solved. But it did stop some of it, and the rate limiting rules that we set stopped the vast majority of the rest. So it would have been very hard to stop this without Cloudflare, but they did flag some of the traffic as coming from a known botnet. So that was interesting. And then the attacks adapted to our defenses. I'm going to actually go into a little bit more details on that in a couple slides. Slowing down, spreading out, switching from few hosts with lots of requests on unique paths to spreading out to many hosts, trying to find rate limiting thresholds, all those kinds of things. I'll talk about some of that. That's kind of interesting. And the attack lasted about 10 days, and low levels of attacks from the same IPs are still going on. So, we saw the attack kind of stop and start, even stopping for like 12 hours and restarting. So, it's possible this is just a lull in the attack, and we'll see more later. So, yeah. It was both. Yep. So there wasn't any single like rule, hey, block all the HTTP 1.1 or block all the, old TLS stuff. There was not some single rule that you could just say, block all this, problem solved. Defending against this kind of attack, there's a number of ways to do it. I'm going to talk about all of these a little bit. it's not one of these things where you just do one of these, you do all of them. It's kind of the real answer. So we were already running a web app firewall. We had a lot of rules already, blocking various things, dropping certain requests that are obviously bogus, those kinds of things. It has more rules in it now than it did. And the same thing with rate limiting. You know, it's obvious to rate limit by IPs. If you suddenly see an IP sending you 50 requests a second, that's probably bogus. But there's a lot more sophistication you can do there. And I'll talk a little bit about that. You have to kind of do all of these things in layers. Caching is really important. Whether you're caching to a CDN, that would be something like Cloudflare, whether you're caching to a local cache like Varnish, something like this, you need to do this basically to prevent this. Like basically any request that hits Python is too expensive. You're going to be overwhelmed essentially immediately. We saw this request at one point. We had hard-coded Nginx redirects, which are like handled in memory. They can handle, you know, tens of thousands a second. We were completely overwhelmed, even on scaling infrastructure. So basically, in some cases, you have to prevent requests from hitting the origin servers completely. And if you can't do that, you will lose, essentially. And the last thing, this kind of gets to that, is network diffusion. How do you handle more requests before they hit your origin? Caching certain things at the CDN, whatever you're doing. So you have to kind of do all of these things together. And a lot of these things, fortunately, are kind of generic. This isn't like a thing that's Cloudflare specific necessarily, even though that's a lot of how we did it. But you know, these caching rules, you can cache to their generic headers that have specific meanings that you put on your HTTP responses, and many different caches or CDNs will all handle the same ones, whether that's, you know, an AWS CDN like CloudFront, I think I got that name right, whether it's, you know, a SaaS CDN like Cloudflare, or whether it's a local cache like Varnish. Go ahead. We are using Cloudflare's web app firewall in this particular instance, but there are local web app firewalls, which I'm going to get to on my very next slide. So I am gonna talk about that. I wasn't gonna forget about. I don't know if y'all have seen this. If you've ever browsed like Linux kernels type stuff, you've probably seen this. So one option, the nuclear option, is essentially you challenge every visitor, and we really didn't want to do this. This basically means rather than serving a page directly, something is going to pop, kind of an interstitial splash screen is going to pop up. It's going to challenge the user, execute some JavaScript, do some sort of proof of work, something, and only when they pass this that we're sure it's a real user, only then does it actually pass through to the origin server. So this is kind of what Cloudflare's I'm under attack button does. If you've seen this is from Anubis, which is like a local open source web app firewall. It runs on your web servers. You can run it anytime you see a lot of these sites. You see it a lot because Anubis, even they say specifically, you know, Anubis is not as powerful as Cloudflare. With that said, there's a lot of things that are, in some ways, it has options that Cloudflare doesn't have because it runs on the server itself. So for example, one of the reasons why a lot of the open source people like Anubis is not just because it's open source, but it can adapt to how loaded the server is. For example, challenging users when the server is loaded, and this will automatically scale down to not challenging users when the server is unloaded when the attack stops. So this is kind of powerful. Anubis has a lot of features that Cloudflare has, not as many, but some different ones. And so I did want to talk about this just as one option. So Anubis is kind of an open source web app firewall, and a lot of small web or Linux kernel type stuff has started to use this. Cool. Another option, what we wanted to do, we didn't want to just challenge every user, drop all the requests from well-behaved bots, those kinds of things. We wanted to have targeted rate limiting rules. And both Anubis and Cloudflare support this, so it's not like Anubis doesn't support rate limiting rules. Anubis can totally be configured in many different ways. And this is essentially you're counting requests that match a certain feature set or certain features and challenging or blocking requests when a threshold has been exceeded over a period of time. So in this example, I have 720 requests in 3 minutes that are uncached, so not cached at the CDN level, then block that IP for an hour. That is what this rule does, and this is kind of an image of that rule in the Cloudflare dashboard. But one of the nice things I also wanted to talk about is at my company, we manage these rules in a tool called Terraform, which is it's an open source tool. It lets you run and store some of your infrastructure as text files that you can version control in Git, have comments on that you can discuss when you want to change something rather than just changing it in a dashboard and forgetting why you changed a particular thing. You can change it with a pull request, which is really nice. We've had a flurry of pull requests against our rules over the last week. But one of the things, so rate limiting is a classic way to try to defeat a DDoS attack. But there are ways that DDoS attacks can attempt to defeat rate limiting. This is one of the things, this is called a yo-yo pattern, which is basically scaling up and down an attack. It becomes even better once you figure out what the rate limiting thresholds are, because you can get to almost exceed the attack, scale back down, get to almost. So they were constantly probing us, figuring out what our rate limits were, what our thresholds were, what our mitigation timeouts were, those kinds of things. And then they would craft an attack that adapted to those. So we saw that it took a few days, but we did start to see that. And on auto-scaled infrastructure that auto-scales on something like AWS or something like this, they're just spending your money, essentially. As you scale up to handle more requests and then scale down, they are essentially just spending your money, which is cool. Yeah. So this, if you look at the volume here, it's actually not that high relative to some of the other peaks. This was, they'd already dialed in their attack. They knew exactly, when they were going to trigger rate limits, and they were trying to get almost to the rate limit and scale back. And again, a lot of these rate limits, they're managed at kind of at the edge at a CDN layer. So if you distribute your attack globally, you can, because all those individual counts are happening at different co-location centers, they can try to overwhelm the origin servers by almost reaching or by exceeding the rate limit threshold globally, but not exceeding the rate limit threshold on individual colos. So we definitely started to see that. Fun. I think somebody talked about IP blocking. IP blocking in this kind of an attack is essentially worthless. We saw millions of IPs hitting us, and in a lot of cases, these IPs were hitting us like 25 times total, which is a normal amount, and then never hitting us again, or not hitting us again for days. So it was very hard to just say, we're just going to block millions of IPs. Basically, that might work for some attacks, but I don't think that's going to work for this attack. We essentially didn't take that path. There's a number of issues with that also. A lot of the attack was coming from data centers or hosting providers, and those IP addresses are going to be reused by legitimate users or legitimate bots in the future. If somebody is using AWS to hit us, which we saw, and then that IP for AWS gets reused, you may basically have blocked people who you didn't mean to block. But there are a lot of things you can do. You can focus on the request and attempt to see what the attacker is doing. You do need things that adapt automatically, but there's also things you can do once you've figured out little bits of this attack to adapt to the attack specifically. So we saw bits of the attack coming from hosting providers, but actually most of it was coming from tiny hosts, like very small hosting providers, WordPress hosts, things of that size, rather than like the big boys. Again, probably a botnet. You can look at, do these malicious requests display any sort of pattern? Are they using old versions of HTTP? Almost every modern browser uses HTTP 2 or 3, but a lot of libraries like the Python request library use HTTP 1.1. You can block or rate limit those at a different threshold. You can block or rate limit old versions of TLS at a different threshold. This really didn't work in this attack. All these things were kind of spread out. They were using everything, essentially. Another thing that I'd be kind of like, again, not super useful in this attack, but somewhat useful generally, is what they call JA4 fingerprints. And this is essentially if a request is made and it uses kind of the same ways to set up the TLS connection. It uses the same cipher suites, for example, which are in the TLS, the first couple messages. This is essentially a hash with various bits from TLS. And essentially, what you end up with is a fingerprint where like every Chrome on Windows has the same fingerprint, but likewise, everybody using Python requests on Ubuntu 24 uses the same fingerprint. And so you can kind of say, hey, what are kind of my normal levels for various fingerprints and what are kind of excessive levels for fingerprints. The other thing, if somebody is distributing an attack by having, say, hey, I have this Golang script or a Golang program, and I'm spreading it out over thousands of machines, thousands of IP addresses. If it all runs in a the same Docker container, it's all going to have the same fingerprint. And so when you start to see requests that have the same fingerprint, but maybe they're geographically distributed or coming from only a couple IP blocks, that can be something that you can introspect in the attack. This was not super helpful for our attack. We've seen this in the past. These have been very useful for us in the past, but in this attack, they were randomizing their TLS ciphers and those kinds of things in order to not have the same fingerprint. So this was not very helpful here. But it is something to keep in mind. Yes? No. Even like you could count anywhere where TLS is being terminated, you can calculate this fingerprint. It's not something that you need to like view packets over the, I guess you do sort of need to view packets over the wire, but you just sort of need to view, you need anything, if you are terminating TLS, you could calculate this on your own server. If something like Cloudflare is terminating TLS for you, then they can calculate this on their side. So it kind of depends. It has to be calculated where TLS is terminated. So if that's on your host, for us, Cloudflare was calculating this for us. If you are terminating TLS, if you have your own server private key that is the private key used in the TLS connection and you're doing this on your own server, you can calculate this on your own server. Well, a WAF has nothing to do with TLS being terminated. If you are running HTTPS, you have and you are serving the private key that encrypts the connection, then you can calculate the fingerprint. But if you're not, then you can't. So if your CDN is terminating TLS and then it's communicating separately to your origin server, which is very common for something like Cloudflare, then you cannot calculate this fingerprint directly.
So from the WAF to the internalized, that should be our certificates, internal certificates, and if you don't have that, you're not getting any further inside.
I think we're talking about different things a little bit.
Where are you calculating this? In your particular case, are you doing it?
Cloudflare is calculating this. Okay. We could not calculate this in our particular case. So it depends. It depends. So you can run Cloudflare such that it is not terminating TLS for you, or you can run Cloudflare where it is terminating TLS for you. We are running Cloudflare such that it terminates TLS for us. You do not have to run it that way.
If you were not using Cloudflare, would you use Nginx? Or what would you
Well, we still use Nginx.
But to calculate this?
Yes, you could calculate this in, probably not in Nginx directly, but with an Nginx extension. Yeah. Yes. So assuming that the private key is loaded into Nginx, then yes. But for example, if you're terminating HTTPS at something like a load balancer, maybe not. So it depends. Like if AWS is terminating TLS, then the load balancer has to calculate this. Yeah. So it depends on where TLS is terminated. Yeah, and this is not a JA4 fingerprints are not a Cloudflare specific thing, but Cloudflare can calculate them. And then also, if you want to, and I think this requires more expensive plans, it's possible for Cloudflare to pass the JA4 down to your application in an internal header, in a request header that only goes to your application, but doesn't go in a response header, and then you can vary what you're doing knowing the JA4 if you want to. So you can pass that essentially on. And in Nginx, it would work the same. Nginx would calculate this and essentially attach it to the HTTP request that would go to a Python web process. This has nothing to do with whether the attackers get further in or not. That is kind of like a irrelevant, like that's like saying, this is just another feature of the request. So this is like having an HTTP header, or I mean, it's not an HTTP header, but it's like having an HTTP header. You can have rules based on the JA4 that are handled at the web app firewall before they hit the origin server, but every request has a JA4 if it's over HTTPS.
I've used TLS certificates as a way to say, depending on how to control the devices, this is where, you have to have, the correct certificate to get this far.
Got you. That's different. That's a different type of certificate. That's a TLS client certificate. That is not this. Were you going to say something different? Yeah. So TLS client certificates work that way. So you can say basically, we drop any requests that don't have the right certificate. So you kind of pre-distribute certificates through an external channel, and then only users with the certificate can even connect to the origin at all. That's not the case here, because I want regular users to connect to these websites. This is a public website. Yes. I mean, there's still certificates, but the certificates are used to verify that somebody is connecting to the correct origin. So it's a different certificate. It's not a client certificate. It's just a regular TLS certificate. Anyway, so yeah, hopefully that was fine. I just wanted to show this off because I think this is fun, and this is like a throwback to 20 years ago. I don't know if anybody remembers the low orbit ion cannon. This is like not a DDoS attack. This is for doing a DOS attack from one host to one server. If you recruit enough patsies to all hit it at the same time, then it is a DDoS attack. But this is just kind of a fun tool that I don't even think this would do anything anymore. But I think this was cool 20 years ago and wouldn't do much today against most sites. Anyway, I have various resources, and then I know we kind of answered questions, but did anybody else have any questions? Yes. Yes. Okay. I work for Read the Docs.
Okay. And was there a point during the attack where you were almost to the point of just unplugging the fiber cables in the data center?
No, because the data center is at AWS. I would probably get shot first. Actually, this attack didn't, I mean, our servers flapped a little bit. I don't want to say like our uptime was perfect through this, but like this attack, I don't think it accomplished what the attackers were hoping for. We were able to mitigate this attack pretty quickly, and kind of our off-the-shelf rules mitigated it. They adapted to those, and then we were still able, our uptime is still better than GitHub this month, but I don't want to, I'm not trying to talk trash too much on them. I'll talk a little bit of trash. We're in East. No, we did not, because we were in East 2, or whichever one was not hit. But no. I don't want to throw shade at GitHub too much, because like I'm sure that whatever we see, they see times 10 or 50. So, I don't want to really throw shade. I was cracking a joke. Go ahead.
I have a few questions. So first question, just to be clear, the JA4 rules are being applied by Cloudflare's web application firewall?
Yes, but you don't have to do it that way. We are doing it that way, and I think that requires a pretty expensive Cloudflare plan. But you could, in theory, calculate the JA4 on Cloudflare, pass it to your application, and do your own things there based on that, apply your own rules based on that. I don't know if Anubis will calculate JA4. I mean, as long as TLS is terminating on that server, it could, or you could pass it in a header and it conceivably could, but I don't know if it does that because I don't know Anubis as well. But other CDNs, other firewalls could certainly work with the JA4. JA4 is nothing, it's not a Cloudflare specific product or calculation or anything. And you can derive it yourself even.
So, and then my second question is, read the docs. Isn't read the docs for the most part static content?
Yes, but there is a lot of, so read the docs is a lot of static content, yes. And this attack specifically targeted things that were not static content primarily. So it primarily attacked, as I talked about this on kind of the early slides, they specifically targeted things that would not be cached. So 404s, unique paths, 302s, those kinds of things. And they were sending the levels of traffic where even like doing a try file to an S3 bucket would be overwhelmed, especially if you actually need to do a try file on like 4 different files because you're like, oh, try this one, then try this other one, then fall back to this, and maybe do some software-defined networking to canonicalize the domain for this particular project or something like that. So yes, read the docs is mostly static content, but we do have, there's some kind of dynamic networking and dynamic requests in there. Was that your last question, or are you good to pass it off? All right, Pat, let's go, Hobson.
I think they might not have been trying to take you down and rather trying to find things that you didn't want public, like security tokens and keys, because that's the only thing of value. They don't have any value in taking you down. It's either they're trying to get your docs, or I mean, if they're guessing random paths, that's a common technique when you're looking for something at a path.
So this was not that. And so we have a bunch of rules for that because we see these scanners all the time that are looking for .env or .git or all these sorts of things. This was not that. This was, let's make up a new path and try it. They weren't looking for anything. This was definitely a denial of service.
You're a host for other services, so it's those people's secrets that they might be looking for in their docs that they accidentally included as files that they're serving on your server.
But all of these come out of Git repos. Like you could sync the Git repo and crawl through the entire history, and that would be way faster than this. So, I don't think that's what they were doing. Is the long and the short of it. We do see credential scanners. This didn't look like that. We see those a lot. What? Yeah.
RTD.
Yeah.
But it could have been a poison attack, a poison source attack, to get to the documentation to attack LLMs.
They weren't trying to add anything because there's no way to add anything on the hosts that they were attacking. Yeah, they were just HTTP gets, lots of them.
What is your guess what they were trying to do?
I think they were trying to take us down.
Why?
I don't know. That I don't know the answer to.
There's a lot of people making money off content, and there's a lot, scraping content just to learn from it as the tokens.
I am well aware.
Money off crypto tokens and other keys and tokens. I don't know if anybody making money off taking read the docs down.
I don't think that they were trying to make money. I think that they had some ulterior motive here, but I don't know what it is. It could be. We were the test attack, the test place to test the bot.
There's one tiny problem with that. Did you collect, if you were the test environment, and we're assuming there's a real botnet, did you collect like all the IP addresses and then feed them into say Cloudflare
I mean, Cloudflare collected all the IP addresses, and then we've been in contact with them since then. So I mean, I don't know what they're going to do with that information. So yeah, but Cloudflare, you know, automatically, and then also in discussions, because we've been in contact with Cloudflare after this, they essentially told us, yeah, looks like a botnet. Some of it was automatically flagged as a botnet.
Wouldn't you basically neuter your own botnet by anyway?
I don't know. Yeah.
What's the biggest country of origin for like the botnet?
United States.
Right? Were
Yeah.
most of them residential IPs?
No.
So, oh, you said shitpost.
So most of it was like, yeah, like hosts that would host WordPress sites, but aren't specific to WordPress, like sites, like networks that are hosting, you know.
All WordPress sites got pwned recently.
Yeah, WordPress sites getting
It wasn't, I don't want to, it wasn't WordPress specific. This was all just small hosting providers, but there was a mix of other things. There was a mix of residential IPs. There was a mix of, you know, the big clouds in there. But the biggest IP blocks, the biggest kind of networks were kind of these smaller hosting providers.
Oh, yeah, because they don't usually require much data.
Yeah. So it wasn't, this attack was very geographically distributed, very distributed across, you know, everything. Like there wasn't like some simple pattern like, oh, I'm just going to block this one country or no. The US was the biggest single part of the attack, but I think that's just because there's a lot of hosts in the US.
Block America?
Yeah, I'm not going to block America. Yeah, go ahead.
Talk about like challenging the user, like give us more examples of that.
Okay, yeah, I can talk about challenges. So this is what a challenge looks like on Anubis. But maybe it's just because I'm a Linux user, but I get challenged a lot, just generally using the web. Where you see kind of an interstitial page. It might even have a Cloudflare logo. You can customize that. And you sometimes have to like just check a box. Sometimes you see one with a CAPTCHA. Maybe it's got Google reCAPTCHA and it takes you to an interstitial page where there's a CAPTCHA or something like that. That's what I mean by challenge. And so kind of with Cloudflare and with a bunch of these other products, you can kind of escalate the more you're sure something is malicious. You know, you might say, oh, maybe it's a little malicious, maybe not. Maybe I'm worried about having challenging too many real users, which we did not want to do. We wanted to challenge no real users as much as possible, but you have to prioritize keeping your services up. So you might start with something that just takes them to an interstitial page and then automatically takes them to the next page. The next layer of a challenge might be, hey, you take them to a page where they have to click a box. Okay. The next layer of a challenge might be something where you just outright time out the IP block, the JA4, some combination of these things. You just time it out for half an hour or an hour. You just say, drop any requests from this for half an hour or an hour. So these are all kind of options. And you kind of like layer it up as you're more sure that this is malicious. So you kind of, you know, Anubis can be configured in a number of different ways. But one of the ways that a lot of servers I see do it is they do it based on the load on the server. But Anubis can be configured similarly. You don't have to do it that way, but that's one of the powerful things you can do, because if you do that, it's hard to overwhelm a server that essentially is not going to serve any requests until the load is lower or until somebody passes a challenge. So yeah, it can be configured a number of different ways. And even in Cloudflare, there's an under attack button where you click the button and it challenges every request. And we didn't hit that button. We didn't want to use that. Yeah.
I only need this because of the live stream, no slides, but can I see the slide with the URLs on it? I think it's like the last.
Oh, yeah, this one? Yeah. I mean, yeah. So Terraform is something you can manage your infrastructure. You can, yeah, okay, well. Got you. Yeah, there's not a ton of details. I think Fox.io, I don't actually know how you say that. I think they're trying to make money from this somehow, and don't know how that will work precisely.
Another question I had, I was trying to remember too. When you said old TLS, how old? What version?
Well, we didn't do this, but you can do anything here. So you can have a rule that says, you know, like you can have a rule in Cloudflare that says if somebody tries to connect with TLS 1.0, which is pretty old, challenge them. Or they try to connect with something before TLS 1.0, definitely challenge them. Yeah, but you end up with all sorts of weird, like once you start doing these things, you will discover that there are people using your website in weird ways. So for example, like we find, oh, somebody is, rather than hosting with us, they're hosting with us, but then proxying their request to us through some proxy that uses HTTP 1.1 with some ancient version of TLS. So you discover these things when you start blocking people. So yeah,
And it's a lot of the embedded devices that will have the old TLS.
Sure, yeah, because you can't upgrade them. Or if you can't upgrade them, and you know, TLS has moved over the last 5-6 years a lot.
The last version for me was 1.3.
I think that's still where we're at. Yeah, I think it kind of plateaued a little bit. Any last thoughts before we wrap up? I went long, but it was mostly on Q&A. I feel like I was okay on the length of the talk. Everybody good? All right, awesome. Thank you. I do want to thank the speakers, Hobson. I'll thank myself, I suppose. But I do want to thank Qualcomm and Cloudflare. Qualcomm for having us and Cloudflare for sponsoring the pizza. And please, please, please sign up to give a talk at a future meetup so that I don't have to give one. Thanks for coming. Yeah. Well, I'm sad that I'll have to figure out that the HDMI pass-through. Maybe I need to buy a new one.
Framework restricts Halo? Or that's the name of the fancy.
Oh, yeah.
Yeah.
I have a framework desktop that all that training is happening on.
Oh, I see. I started from a little late, so I just like.
Hey, Hobson.
Has the AMD Ryzen AI with NPU?
Yeah.
Although it's kind of the support isn't as good yet. So there's this one software that can run some models, but it can't run everything. I've mostly been using Qualcomm.
Hobson, is this your brick or no? Okay.
Thank you for remembering. If you want to talk about it, I have a weekly get together, a co-working session where we talk about this kind of stuff at your